You are very welcome to a recording of our webinar on the angler's mayfly, Ephemera danica. This recording is in 4 parts. The first section will cover the background to the study and our initial findings. The second part will look at water chemistry in the chosen lakes over recent decades. The third part contains underwater video footage of mayfly nymphs from a selection of different habitat types. Finally, we present our initial conclusions and recommendations. I hope you enjoy our presentation.
So in terms then of the project itself, how did we organize it? Well, the first thing we did was to put together quite a detailed questionnaire. And we were a little bit concerned as to whether or not the questionnaire was too detailed, but we really needed as much information as we could. We also asked that the questionnaire would be spread out amongst different age groups so that we would get a history of what was happening right back into the past. And we were bowled over by both the enthusiasm and the detail that we got in the questionnaires. So to date, we have 48 back, and they're fairly evenly spread throughout all of the lakes that we looked at. But there's a wealth of information in the questionnaires, and we're only beginning to really analyze those at the moment. We did have a quick look at them to influence the original sites that we looked at, but the other information in terms of relative causes and so on, we look at that in the context of the report that we'll be doing now in June. So the first thing I did was to carry out a literature review, and we then got down to the business of planning exactly what we might do. And we did that over the October and November period. The interesting thing is the comparisons that I found when I did some work on this in the past are still very valid. And what's happening in terms of hexagynia, this is the big burrowing mayfly that they have in North America. It's very prevalent in Lake Erie, for example. That was one of the sites I looked at for my PhD. And again, the story is following a very similar pattern to what's happening, particularly on Loch Sheelin. There was a situation where they thought they'd lost the big hexagynia hatch completely. It's now back in abundance. And also they have very large numbers as well, huge concentrations of zebra mussel, which again we have as well. So during the early part of the project then, we held meetings with a series of different local interest groups. The first meeting that we had in Foxford, we had about 30 people at it. So that gave me fantastic enthusiasm because, as Bernie said, everyone seems to be very interested in this particular species, and its importance is obvious, not just in terms of the anglers, but in terms of the actual local community in those areas. Everybody has a story about mayflies, it seems. So the fieldwork then, we started the fieldwork then in December, and that has run right through until May. We just finished our fieldwork a couple of weeks ago. Martin, who you'll hear from in a few minutes, Martin then looked at the data that was available for the lakes, covering quite a number of parameters. So we'll just give you some preliminary results in terms of the phosphorus levels, in terms of chlorophyll and temperature tonight. But we did look at some other parameters through Martin as well. And then, of course, we'll be producing the report then, as I say, in June with the recommendations that we'll actually share some with you now tonight. So these are just maps that we provided in the questionnaire, just to set the scene in terms of the areas that we looked at. So I was just mentioning to Bernie when we were just getting ready for the event this evening, that we were very fortunate in that originally we had mapped out quite a number of areas that we would look at in these big lakes. But in fact, the weather precluded that. And we were very fortunate because just learning about individual areas has taught us so much in terms of what actually is happening. So in the case of Loch Corrib then, my colleague Paddy Gargan, who is now retired, he used to be with the Central Fisheries Board and Inland Fisheries Ireland. Paddy then hosted us several times out in this area here of Loch Corrib. And it was really, we learned a huge amount. It was an ideal base and an ideal location. And you'll see that from some of the underwater footage as to the lessons we learned in that particular area. But we have all of the rest of the lake is very well filled in from the questionnaires. The questionnaires are very nicely geographically spread, and we have a very good idea now as to where the mayfly was originally and where it is now. Loch Mask is a very strange lake. in the sense that Loch Mask is not renowned in an angling context for very large hatches of mayflies, but it is one where the mayfly on occasions is important, and certainly hatches of mayflies are very important to the local community. So we concentrated our efforts on Loch Mask in this area here, because that's the area that is mostly fished for the mayfly. So the angler information we got from the northern end of the lake and from the western end was quite good. So that clearly indicated to us that these were areas where there was no great abundance of mayfly. And these are the areas we looked at. So in particular, we looked at a place called Carrick-Davo, which is the Rock of the Two Cows. We looked at Scintilla and we looked at Inishgurram. And Mask was really interesting because the actual bathymetry of Mask was quite different to any of the other lakes. And the habitat and where the mayflies were in Loch Mask was actually quite different to other lakes as well. But there were plenty of mayflies there as far as we were concerned. We found a lot of individuals there. This was the jewel in the crown, to some extent, Loch Conn. We got, as I say, the first meeting I had was with the anglers from Foxford, but the questionnaires really absolutely nailed it in terms of exactly what was happening. So they had a very good history of fishing particular areas, areas where the mayfly had disappeared, areas where the mayfly was still present. And we'll come on to that in a few minutes. But in reality, this area here, Clohans, the mayfly has all but disappeared out of areas of Clohans, whereas in this area here, up at the top, particularly in where the Deal flows in, this area here is known as Tolan's Bay. This area still has very good concentrations of mayfly, and the area I know best is Castle Hill because I used to fish it when I lived over there, and Castle Hill was as I remembered it. But we saw very few mayfly then in this particular area. But the Clohans Bay one was a revelation in terms of we think what was happening there. Loch Sheelin then, and as we speak about Loch Sheelin this evening, please remember that when I started to work on this in the 70s, particularly in the early years, the early 2 years, I found it really, really difficult to find individual E. danica nymphs in this area here. And you'll see on the video and you'll see on some of the stills just how abundant the mayflies are in Loch Sheelin at the moment. It's almost crazy. The abundance is so incredibly high. And we had a very good opportunity because, I suppose I know the lake so well, but also we had John Byrne, my colleague from UCD. We had John working with us on this as a volunteer. So we were able to cover quite an extensive area in Orangefield. So we covered this area here. We did the area around Orangefield here. We did around Church Island and we did around Derry Sheridan. So I'll give you some of the results on that now in a while. Loch Cara was not included in our list of lakes, but because it had been so hugely important to me during the previous study, I contacted the people who were involved in the Loch Cara Life program, and they were very keen to be involved and to learn the lessons with us. And they're also going to follow through because they have quite a lot of people, both professionals and volunteers, working on the lake at the moment. So the two areas we looked at were Moore Hall in this area here, and this was the jewel in the crown when I was looking at mayfly in the past. This was the area around Brownstown here. The reason was whenever I sampled, there was a huge number of different sizes of mayflies. So different year classes of mayflies, you want to put it that way, were present, which was quite different to the Midland Lakes at that time. But you'll see when we report on it, just the way that has changed in terms of the results. So this is just to give you an idea of the sort of happy hunters that we had with us. So the volunteers and the people that have worked with us have been fantastic. Great level of enthusiasm altogether. I have to acknowledge then the equipment we got on loan from people like Brian Kennedy and Paddy Orr and UCD. I went around beg, stealing and borrowing anything I could get, but it was really, really useful. Then we had all sorts of volunteers. We flew this guy in from the States, and he's with us this evening at huge expense. So we had a really good day with Rick out on Loch Conn. This is some of the equipment then we got from Brian. So these are what we call grabs. So there's two types of grabs here. The one on the bottom is the Ekman. The one on the top is called a Van Veen. And the Ekman is the grab we used mostly when we started off looking at the sediment and looking at the mayfly populations. I won't make any comment on that, any additional comment on that for the moment, because we've a bit to say about that and some nice video to show you the pluses and minuses of using that sort of equipment. So basically, with the grabs, you lower them down to the bed of the lake. You send down then a signal, which is basically a heavy weight that flows along the rope. It then hits the top of the grab. The jaws of the grab then close, and you get your sediment, but only if the sediment is soft. But we actually have video of a full sequence showing you how the Ekman actually works in a few minutes. So the thing that came out very obviously to us very quickly was the layering of the sediments and how complex the layering of the sediments were, and also the variety of sediments where we were finding mayflies and the sediments where we weren't finding mayflies. So basically what you see here in terms of the gray at the top, to me, when I looked at it originally, this really seemed to be a really important feature in many areas, and that was what we call marl. So the sticky limestone marl, to a lesser or greater extent, in the past seemed to be present in a lot of the areas where the mayflies actually made their burrows. And we found a great variety of different types of marl in the sediment sampling that we did. And Margaret McCall, who can't join us this evening, Margaret has kindly offered now, from now on in the lab in DCU, to start looking at some of the samples that we have collected. The results won't be ready for this particular study, but we thought it was important to try and get some science around what the sediments were like that we were where we were finding the mayflies. So the contrast is really between the grey marl that you see here, and then once you start to see this very, very fine sediment, and that's just a small layer on top of the marl, but it was enough to exclude the mayflies. They just weren't in that sample. And you can see where you got a deeper sample then again, and you'll see this very graphically in the underwater shots that Ross will show you. You get a lot of this sort of material gathering around the base of the different types of flora that you have in the lakes. And I'll come on to talk a little bit about the flora and the changes that we may be seeing in the flora. And in conjunction with the changes in the flora, we're seeing the changes in the sediment. If we're seeing the changes in the sediment, we're going to see changes in terms of the abundance of the mayfly that's present. So as I say, wherever we went, we got different sizes of nymphs. We got some that were of this particular size, that guy there, probably about 10 or 11 millimeters. But we were very, very fortunate. The first week in April, we actually got very, very big concentrations on our first two grabs of tiny little nymphs, a couple of millimeters long, which were early instar nymphs that may very well, I suggested this on my past work, they might have overwintered either as eggs or indeed at that very early stage. But we sampled a spot we had sampled several times before, and suddenly these little guys, what I call the tinies, they appeared. And the interesting thing was, as we moved from lake to lake, we were finding quite a distribution of sizes, and that was not the case the last time. It was much more. It was certainly much more consistent in the Midland Lakes in the past study, where we got consistently a 2-year life cycle. So this may indicate that we're seeing a lot of changes in terms of the actual pattern and the more importantly the emergence of the adults over the summer period rather than being concentrated into the May period. So you can see one of these, not super tinies, but you can see one of the tinies there. This is one that was almost ready to hatch, and this is one that probably wait until next year, but may hatch later in the autumn because they do get a good autumn hatch in Lough Conn. And just the ruler there gives you an idea of what we're actually looking at. As I say, I was very keen to know more about sediments because I hadn't done any work on sediments when we looked at this before. So Paddy Orr, a colleague from UCD, was kind enough to loan me some courers. This is just one of them. I'm not actually standing on the water there. I haven't quite developed that trick yet. That's a flooded walkway that I'm standing on, but it offered me a lovely platform to actually sample the marl. And this is, again, the grey marl that we were speaking about earlier. That's in abundance in Loch Sheelin. That was a sample from Loch Sheelin. That was up in the Arley area of Loch Sheelin. These shots are just to show the contrast that you have. And again, you'll see this in graphic form when we look at the movie clips. So you can see here at the upper left of the screen, as I look at it, you can see the actual marl that would be suitable for the mayfly. On top of that, you see a lot of black, very, very dense sediment. We think that has a very high peat content in it, but again, where you had big concentrations of that, it excluded the mayflies. Just an off the cuff comment by Pádraig, who was working with us on the day, sent us into what was called Clark's Bay on Loch Conn, and that gave us an incredible bay of marl. And this is white marl, and this is so similar to what you find on Loch Carra. So again, this is a very good habitat for the mayflies, and Ross's underwater shots will actually be able to show that again in graphic detail. So back to Clohans. So in terms of Clohans Bay, then what you see is the situation where the as far as the local anglers are concerned, and the questionnaires have this outlined in detail, we're seeing quite a fast movement of completely natural plant species, but they seem to be colonizing more and more extensive areas of Clohans Bay. And that's interesting because I did a podcast about a year or 18 months ago where a friend of mine from the River Shore on some little lakes I'd been looking at in East Galway, we suddenly realized that these were becoming clogged with natural growths of these native weeds and native plants, I should say. So again, the anglers were noting this, and that looks to me like Elodea, looks like Canadian pondweed, and there's some carophytes there as well. But the Elodea and also Myriophyllum seem to be the species that are spreading across these bays. Again, you can see in that particular picture, you can see the very fine silt that's gathering, particularly at the base of the Carra and the Canadian pondweed. Okay, and then you had just the beginnings then, this plant in the middle of the shot there, that's Potamogeton. So this has brown leaves, and you can see the brown leaves in some of these areas. So very, very interesting changes. And as I say, the anglers had very clear reports of exactly when this happened, and we were actually able to verify that when we went and we sampled. So that's actually from Loch Sheelin, and that's in the Carra beds in Loch Sheelin. So they haven't changed since I sampled there all those years ago. So we sampled areas where, you know, we didn't think there was any chance of getting mayflies, as well as the areas that we were directed to. And that was a shot, as I say, in the big Carra beds at the base of Loch Sheelin. The Carra beds and the other weeds and plants that I show you, they're really important, because they're going to be producing your buzzards, they're going to be producing lake olives, they're producing all sorts of habitat for snails. So it's not that any of these things are bad, it's just that they're different, and they're causing the mayfly then to do different things. And then came the big surprise, because the question really is, well, if things are changing, can these animals, can they actually adapt? So at the mouth of the Deal, where I showed you near where I call Tolan's Bay on Loch Conn, we started to find, and that's Rick's hand there. So it was with Rick that we had the first discovery of this particular substance. So this, we think, is peat nodules that are covered in calcium. Margaret will be able to see whether or not that's the case when she does her analysis, but they're certainly coated in something that makes them quite brittle. They look as if they're little bits of pebble when you first get them out of the lake. When you riddle away the very fine sediment that's with them, you realize then that you can compress them between your fingers. And in reality, we think this is peat that has then been mixed in with the calcium. And that's what's giving us this particular type of substance. But the mayflies really like that, and they were quite willing to make their home in that very strange habitat. This was something that I first came across many years ago in Loch Earn, where I realized that the mayflies were actually making use of the zebra mussels. And what they do is, where you have big concentrations of dead zebra mussel shells, the mayflies are quite happy to use that as a habitat. Saves them the trouble of having to waste energy making a burrow. And in some instances, they'll even live inside the actual shell. But in this instance, they were between the between the actual empty shells themselves, but very big concentrations of mayfly in those two habitats. So that should give us great encouragement that even if things are changing in these lakes, these insects are going to they're going to actually adapt. So that was an interesting finding as such. That's just to give you a small idea of the densities of mayfly nymphs that were in Loch Sheelin. It was really quite it was really quite extraordinary. And again, you'll see that more graphically when we look at it from the underwater shots. So I'm going to move on then to the next section. I'll ask Martin to take over now. And Martin's going to talk to us about looking at the water chemistry and the temperature trends that he found in the various lakes that we picked where we sampled over the last 6 months or so. So Martin, I'll just pass over to you if I may, and I'll certainly change your slides for you.
Okay. So the Eden Ireland has a fantastic database of water chemistry for rivers and lakes, and there's just a few. I've got phosphorus, chlorophyll, and temperature for the various mayfly lakes that we're talking about. So if you go on to the next one. I'm still saying yeah. Okay, so first of all, phosphorus. Phosphorus is important because it's normally the limiting what they call the limiting element in terms of growth. So if you add phosphorus, plants and algae will grow more strongly because it's the limiting element. And then so in lakes, though, we measure total phosphorus rather than molybdate reactive phosphate because it includes the phosphorus that's actually in the algae. So if we go on to the next one, then I have various trends then for phosphorus over the years. Sheelin on the left, no particular, a bit up and down over the years. Phosphorus, now you might notice that the top value in Sheelin is 0.05 milligrams per liter, which is way higher than all of the other lakes that we're going to talk about. So on the right, then you have Cara. The top value is zero on the y-axis is 0.025. So the Sheelin is a little bit different to the other western lakes, and in terms of where it's going from, I think 2007 up to 2023 on both cases here. So you'll see no particular trend in Sheelin, very high compared to like 0.01 is the high status level for lakes in Ireland. And on the right there, you see Cara is well within it's a little bit above it in some places, but generally below the 0.01. And remember that they can only measure down to 0.005. Like it's kind of it's a difficult one to measure in the lab. Okay, on to the next one then, Ken. So you got Con on the left and Mask on the right, and again, you know, pretty good, pretty low over the years. No particular, a little bit upward trend maybe, but not still pretty good in terms of the overall level. And the next one then is probably carb lower, carb upper, and then in this case it's going down. So the trend, okay, it's okay, these are like there's maybe 5 or 6 values per year, depending on the lake, but it looks like it's going downwards in this case, so that's a good sign. Phosphorus, and it's very, very low. I mean, okay, there's a few scattered points above the 0.01, but in general, its trend is downwards. Okay, then the next one is I've gone on to Ken. Like I'm still saying carb.
Sorry, Martin, it's just caught. Give me just 1 second.
Yeah. I think we're going on to the chlorophyll then. So chlorophyll is it's used to assess the level of algae in the lake, basically. And if you have too much algae, then your visibility is affected. And okay, everybody wants green this, green that, green the other. We don't want green lakes because that's a bad sign. If there's too much algae, like say for example, Loch back in the 70s, it went green all year round, and the whole lake was in dire straits. Okay, so so these are the chlorophyll values then for the next. So again, Sheelan on the left again, much higher values than most of the other lakes we're going to look at. Cara is quite high too, but then the trend is downwards. And it's actually interesting because I was talking to one of the people that were working on La Car, and they were saying it's that they didn't think it was getting better, but actually it is going down, particularly in the last number of years. You can see the chlorophyll values dropping, and that line, the blue line in the middle, is going down. Okay. Next one is mask and con and mask. So con on the left, and again, downward trend. And okay, there's a very high value back in 2000. I think that's 2007 is the first year. It's 2007 to 2023. But after that, the trend is downwards. Now, there was a change, I think, in the lab analysis. You can see there's a kind of a jump down on the more recent ones from 2016 on, where I think that their level, what they call the limit of detection, has improved. It's gone down. It's not a real thing. It's just that they can measure it a bit better than they were. Okay, so they're pretty low. And then the next one is Corrib, upper and lower. And again, the same thing there. You can see that jump is not. It's a lab thing rather than a real. But at the same time, the levels are going down. Corrib, those values are pretty low by any standard, really. And then the next one is temperature. Then okay, so that's interesting because I was talking to Ken there the other day, and when you look at temperature, it's a bit difficult because we're looking here. We have temperatures that are measured on the day that they take the samples for the regular chemistry, and really we need continuous monitoring. We need to know the lows and the highs over the course of the day and over the course of the year. So if you look at there's no next one, then yeah, I mean this is Sheelan. It's level. There's no particular trend. But again, remember, these are just particular, they're maybe 5, 6, I'm not sure how many times a year. So that's each year going from 2007 up to 2023. There's no particular trend in temperature there. Okay, and the next one, mask. Now, if you look at mask from way back, 2007, it's a downward trend. But then if you look at the more recent ones, it looks like a slightly upward trend. But again, we do really need the kind of continuous day and night monitoring, the kind of stuff that Pete is doing. Again, Cara, slightly upward trend, which is probably what we'd expect in terms of climate change, and that we'd expect things to be getting higher and higher as the years go by. And in the more recent, there's a slight upward trend, probably not very statistically significant, but it's up. And then the next one, I think, is con. The same idea here. On the left, you have the full trend. Looks like a downward trend from 2007 to 2023. But then in the more recent years, from 2017 to 2023, slight upward trend. And I think the same then for the next one, which is Corrib lower. Again, slight upward trend. And remember, these are big lakes, so but the temperature is only measured on daytime when the EPA or whoever is out sampling the lakes. So Corrib slight upward trend, which is probably what you'd expect. And then the last one, I think, is, yeah, that's it. So just concluding that phosphorus appears to be increasing in some lakes, but the levels are very low. They're really down at the kind of high status environmental quality standard from the point of view of the Water Framework Directive. Sheelin is the big exception. And then chlorophyll levels are improving, lower over time. And then, okay, there is obviously the whole thing about the zebra mussels. The zebra mussels will soak up the chlorophyll, and like in some lakes, it looks like it's gone off a cliff in the recent years when they take effect. And then temperature trends increasing in recent years, and over the longer term, it looks like they're stable or decreasing. But again, caveat being that they're just spot samples, though, they're not really. We need continuous measurements, more like the Met stations have. You need to know the high and the low day and night. Okay, that's it.
Thanks very much, Martin. Okay. I'm going to ask Ross then to take over. Ross is going to look at the underwater shots then that we did, and some video then we took above water as well.
I was lucky enough to be able to do the most fun part of the project, I suppose. I've spent a good portion of the last couple of months under the surface of these lakes that we've been talking about, using snorkeling as a method for surveying Ephemera danica habitat, and it was a fantastic experience, actually. But just to start off with, as Ken's already said to you, and throughout the talk, I'll try to limit the amount of repetition, but inevitably there's got to be some. As Ken has already said, the traditional methods for sort of lake bed sampling in these sort of circumstances where you're trying to get sediment and invertebrate samples is to use something along the lines of an Ekman grab or Ekman dredge sampler. These are very useful devices, but they certainly have their limitations. So I'm just going to firstly show you how the sampler operates. Those of you familiar with them may not have actually seen them in use at the lake bed before. So if you find a nice bit of soft sediment like this, they're great. Your weight flies down from the top, sets off the triggering mechanism. The jaws of the grab close, and the sediments are trapped within and are brought safely up to the surface, where you hopefully have your sample of mayfly and sediments, which you can inspect. As you see, the sediment comes out here nice and clean, and it's a brilliant tool in these sort of circumstances. But it does have its limitations. It doesn't work at all in rocky areas, and then if you're even on a good area, you often are unfortunate enough to snag something which causes the jaws to stay open, like this stick in this video here. So all the sediment falls out the bottom, and you get no sample at all. In an area like this, you could of course just drop it down again. But the big problem really is that you're totally limited by the lake bed type, and so you get a very biased range of samples. You're only really getting samples from those areas of soft lake bed. So moving on to the next video here. Snorkeling, in contrast, has a number of key sort of benefits over the Ekman grab. Firstly, for me, it allows you to really observe the heterogeneous nature of the lake bed, get an idea of the various lake bed types that you have, the different substrates, whether it be rocky bottoms or silt. And what also I was able to do was actually sample Ephemera danica nymphs from various different types of areas, not just the soft bottomed areas. And then at the same time as well, get a quite a good visual idea of the characteristics of the sort of areas that the mayfly were using. So just to give you an idea here of how I tended to sample the mayfly, it was to go down to the bottom and then use my hand to wave kind of rapidly over the lake bed. And even in rocky areas like this, what it did was it disturbed the water just above or just through the surface of the lake bed. It forced the Ephemera danica up into the water column, and we were able to then, capture them or get an idea of the numbers that were in each area. And we were able to do this actually in a sort of semi-quantitative way as well, where you could over a period of time wave your hand up above the surface, and then move a net back and forth, almost like a kick sample in a river, and get quite a good quantitative estimate of the number of mayfly in an area, the sort of density that you had. So that bit of footage there was from the first day on Loch Corrib. We went out to the area around Devonish Island, and we immediately found actually really good numbers in this sort of habitat, this sort of stony, gravelly lake bed. But what was really interesting was that, and then those mayfly, by the way, were right the way into about 10 or 15 centimeters depth of water, and at this stage this was still in a period in time when the lake levels were very high, much higher than usual, meaning that the mayfly had actually moved in to colonize those areas since the water levels had risen, and presumably then will retreat as the water levels drop. But what was particularly interesting around Devonish, and we found this in general, was that the area of the lake that was actually used by the mayfly was really restricted. Around Devonish, for example, you had an area that maybe extended out about 30 meters or so, and there'd be large numbers of mayfly through this area. But then when you moved out a little bit further and got a bit deeper, you got this sudden transition, and you'll see it in this video now. So on the right hand side of the screen, you've got the productive mayfly habitat made up of rocks and gravel, and that's basically what you just saw in the last clip. And then out on the left there, you suddenly get a very light silty bottom covered in charophytes and other plants. So you'll see now in the next shot, this is as you go out a little bit further, it becomes pure char. The lake bed is totally covered, and underneath the char you'll see now is this very fine, very light silt, which seems to be completely unusable for mayfly, even though in these areas you will have large numbers of lake olives and buzzards or chironomids utilizing these areas. So it's not necessarily bad, but not productive for mayfly. And then as you go further out again, you start to see the plants starting to dwindle, the odd one here and there, and then as you go out a bit further again and get into deeper water, you get this what almost looks like a sort of desert landscape that extends out for huge areas of the lake, and again is covered in this extremely soft sediment. These areas appear to be totally unusable for mayfly, and it just, I think, goes to show that the areas of the lake where Corrib is of course renowned for being a productive mayfly lake, but the areas that they're coming from in some cases may be extremely restricted. In the case of Devonish, for example, probably about 30 meters out from the island, and that would be during periods of high water. When you think of low lake levels and the shoreline being further out, that would be an even more restricted area. Then moving on, so that was really the take home, I suppose, from the Corrib sampling, was how restricted the mayfly habitat can actually be. Then our findings from down at Con were that in certain areas, such as around Tolan's, you had similar sort of habitat to what we found in Corrib, and again, this sort of habitat that you're seeing here, made up of small pebbles, some bigger rocks, and a lot of zebra mussels. These areas were generally reasonably productive. However, when we went to some areas that were traditionally known for being very productive mayfly regions, but have there's anecdotally been quite a drop off in recent years, and the mayfly hatches have been much less productive. We found interesting patterns. So, for example, here this is filmed in Cloghans, an area that in the past was well known for mayfly. And when we went down here, we found again this very soft, silty bottom, big beds of charophytes kind of blanketing the bottom, and no sign of mayfly at all through these areas that historically were apparently very productive. The bottom in this section here was very soft silt sitting on top of a marl bed. So there was, you'll see in this shot here, you've got the very soft silt on the kind of on the right hand of the screen, and then beneath that is the marl, the white marl, which is much more solid. And in some sections here, the silt on top was maybe 20 or 30 centimeters deep. And again, with it being so fine, I believe that it probably limits the flow of oxygenated water past the gills of the mayfly that burrow in, and so makes those areas effectively unusable for them. This site now is further up to the north, where close to where the Deal runs in, and this was particularly interesting because at first glance the lake bed here looked again like the very fine silt, but it was a sort of a mix of the marl and the silt. It was more gelatinous, a bit more solid, and again, as Ken mentioned before, it contained these sort of granular, possibly peat based granules that you see here. So this is some of that material you saw in the last shot that's been filtered so that all the silty stuff has been removed, and you're left with these granules and again mayfly nymph. So these areas were surprisingly productive when at first glance they looked like they were going to be barren, but the mayfly were there, and we saw various life stages in these sections. The next lake that we sampled was Loch Cara, a fantastic place to snorkel if anyone is ever keen. Great visibility and a fantastic example of a marl-bottomed lake. So this bit of footage here is from Moore Hall, and at the Moore Hall area there was a particularly interesting pattern whereby the mayfly nymphs were really to be found only within about 30 to 50 meters from shore, even though there was no dramatic drop off after that, and the bottom of the lake didn't appear to change very dramatically, but I just stopped finding mayfly as I went further out. So this is that marl, really pale and sort of quite solid in its way, and you can see the mayfly nymph there that was in it, so down maybe about 2 centimeters, 2.5 centimeters from the surface. And this shot's a little bit long, but it's just to give you a bit of an idea of how the mayfly firstly swim. Any anglers out there might want to think about how to replicate this, and also just to get a bit of a view of how the nymphs actually burrow into the marl. Takes them a bit of time, but of course during the daylight hours they're primarily going to be underneath the surface of the lake, so being able to burrow down through this layer is key, and then primarily coming out at night to feed on the surface of the lake bed. So there he is, sort of popping down. As you go a little bit further out from Moore Hall, you start to find these lovely cara beds, which run out quite extensively further out into the lake. But what was interesting in Cara, in comparison to most of the other spots that we sampled, was that even where you had vegetation growing, you tended to also have directly underneath still a pure marl base, and none of that sort of dark material that you tended to see associated with charophytes in other areas. It sort of suggests that the annual decomposition of the plant matter in these areas doesn't result in any sort of thick layer of dark organic material on the bottom. And then the final lake that we sampled was Sheelan, and this in terms of productivity was the absolute jewel in the crown. It was absolutely phenomenal for various invertebrates, but particularly for mayfly. When you found the right spot, the densities was absolutely unbelievable. The nymphs were to be found in all sorts of substrates in this part of the lake, whether it was gravel-based or sand-based, whether it was marl or along the rocky shores. But you just see the vast number of nymphs that are through here. I mean, you could take a handful of the bottom here and come out with 10 or 15 mayfly nymphs. Really just phenomenal densities compared to everywhere else that we went to. This is another area, much more sandy bottom, but again, really, really high numbers of mayfly nymphs to be found effectively everywhere through this region. And this was all really between Kilnard and across to Church Island, was where we sort of focused our sampling efforts at this point. But huge numbers of mayfly larvae and very large larvae as well. You'll see now in the next shot when we attempted some quantitative sampling there, we I think I did about a 20-second sampling with a net just above the bottom where I was moving my hand, and I think 20 seconds resulted in about 210 mayfly nymphs. So just phenomenal productivity. Another aspect of the productivity that was evident in Sheelan was the density of zooplankton in the water column. But just getting back to mayfly first, the mayfly themselves in Sheelan, the limiting factor in terms of their distribution in that part of the lake that we were discussing was really all down to depth. I mean, some of the shallower areas were more productive than others, but what really seemed to determine where you found mayfly and where you didn't was depth. So up to about 4 meters, you had vast numbers of mayfly. Between sort of 4.5 and 5.5 meters, you had this quite marked decrease in the mayfly numbers. And then somewhere between 5.5 and 6.5 meters, the mayfly disappeared entirely. I just could not find them below about 6.5 meters. And this sort of vertical effect on distribution was, I suppose, also replicated in the zooplankton populations. So, well, this shot here actually is just again a bit of sampling for mayfly there, but finding them in a more marl-based bottom rather than the sand and gravel of the previous shots. And again, very, very high numbers of mayfly to be found in these sections. And you'll notice again, I think in this shot, you'll be able to see quite clearly how strong swimmers mayfly nymphs actually are. I think people often think of them as sort of moving very slowly through the water column and hovering up, but they actually have a very rapid pulsing swim rate. So this shot here gives a bit of a sense of the zooplankton in the water column. Up towards the surface, the water clarity in Sheelan didn't look that great at first, and I thought actually it was full of sediment, suspended particles. And it was only after pausing for a while I realized that this milkiness that you're seeing here and all those little dots catching the light are vast numbers of zooplankton that if you stay still and look at them, they're all swimming along actively. But as you go down, you all of a sudden hit a point where the zooplankton disappear, and all of a sudden you've got clear water again down below. And you'll see that looking up from the bottom here now, you'll get a bit of a sense of the sort of clarity down the bottom being actually very, very good. And then as you ascend through the water column and come back up to the surface, you start to get into the thick clouds of plankton, and water clarity starts to decrease quite markedly right up towards the surface here. And all of this is presumably driven by light penetration and I suppose phytoplankton growth through the water column. As Ken's mentioned already, zebra mussels were a feature of most of the lakes that we looked at. And I just put in a few shots here just to firstly show how they actually colonize the rocks and how plentiful they are. This is a shot from Loch Con. And in Sheelan, it was even more incredible the quantities that I found. I mean, this is a section where zebra mussel shells have gathered to a depth of probably 8-10 inches deep. And I suppose over a relatively short amount of time, this has happened. So a huge effect on the substrate on the bottom of the lake, and then also a big effect on chlorophyll and water quality through their filter feeding. But of course, this is going to have an effect on light penetration too, and it's all, I suppose, interrelated. Then this is just a final shot from under the water in Sheelan. This is down towards the Finney side of the lake, where again the vast numbers of sorry, I don't know what's posed here. Sorry, just one moment. Again, the vast numbers of plankton are evident in the water column. Huge densities. But down this section of the lake, you find much more beds of chara, much more habitat that is known for producing lake olives and chironomids, but virtually no mayfly. And what was quite interesting was when you had a look at the lake bed through these areas, the composition wasn't visually that different from some of the areas where mayfly were found in profusion in the previous sections of the lake. So it'll be very interesting to see what a sediment analysis might reveal about the differences between the areas and possibly give us some insight into features of mayfly distribution in all of these lakes. And then finally, I just have a quick shot from the shores of Loch Sheelan that I recorded a couple of weeks ago. I suppose it's a site that would get most anglers quite excited. But it's really just to highlight the fact that so far this project is really only focused on the larval stage of the mayfly life cycle, and as such, this has been a fairly restricted project that, you know, in the long term, if we're to really try and understand population dynamics over time or across space, we really need to look more broadly at all stages of the Ephemera danica life cycle. So that's it for me. Thanks for bearing with me.
Okay, this is difficult to do because there's obviously an awful lot there, but just to give you some take-home messages, really. We were really surprised at how clumped the distribution was, and that considering the size of the lakes we were dealing with, the areas we covered, certainly they were in relatively restricted areas, which obviously is one of the danger points, I suppose, in terms of changes in the lakes, because if it differentially affects those areas, it's going to affect the actual populations of mayfly. The other thing that was very surprising was the sediment composition of the lake beds. It's extremely complex. I would have thought that there would have been much larger areas that would have been very similar, but it was very complex, and again needs to be looked at and carefully planned in terms of how you would actually try and assess that in some sort of quantitative way. As Ross mentioned, the really high abundances of nymphs then were restricted generally to areas less than 4 meters, yet we still had mayfly present, but in decreasing numbers out to about 6 meters. But beyond 6 meters, Ross, in this particular study, could not find any at all. Again, as I mentioned earlier, the smaller nymphs, which I think are really important in terms of this whole question as to whether the actual emergence time of the mayfly has changed, is it now spread more over the summer, particularly with 2 peaks. And this would have been traditionally the way the mayfly emerged in Loch Cara. you would have had a peak around the 1st or 2nd week in May, another peak then in July, and you would have had mayflies hatching throughout the period from May right through until October. And this was reflected in terms of the length frequency distribution of the nymphs at the time. And this pattern would appear to be developing in some of the other lakes, which I think is really important, because if the actual peak concentration of your hatch is more spread out, you won't get anything like the same angling as you would if the emergence was concentrated into a few weeks. Their surprising ability to adapt to novel habitats was really interesting. As we mentioned, the peat nodules and also the zebra mussel shells. And as I mentioned, I think as well, I saw that for the first time in Lough Erne near Lusty Beg Island many years ago. There was indications of changes in the distribution of various floral species in some of the lochs. And there was certainly possible changes in sediment types in some of the bays, in Conn in particular, and Clons. The very abundant zebra mussel concentrations, those densities that we saw in Lough Conn, really surprised me. If anything, the densities in Conn did appear to be even more concentrated than they were in Sheelin. As Martin outlined then, total P was increasing in some of the lakes. Chlorophyll seemed to be lower over time, and temperature trends may be increasing in recent years. So I would totally support what Martin was saying earlier. Really what we're looking at here is a situation where we need to have much better data over a much more concentrated time period, not just single samples over long periods of time, but really looking at particular areas of the lake and how that is changing. Obviously, we only examined the nymphal stage, and as was shown in earlier studies, the variations you can find as a result of what happens when they have emerged, particularly big storms, changes in wind direction, temperature dropping very fast, hailstorms, anything like that can have a catastrophic effect in terms of the adults getting back to the water to lay their eggs. The other thing to remember is that we're looking at changes, as we all know, in our aquatic systems that we think are linked into climate change, linked into man-made influences of various sorts. But the burrowing mayflies have always shown this strange dearth and abundance type cycle, huge variations in terms of abundance, both in terms of our own species here in Europe and the species in North America. And the natural cycles are very clear from the Inland Fisheries Trust reports, which we're lucky enough to have copies of all of the IFT reports. And they're really chatty. And they describe in great detail each of the mayfly seasons and what happened during the season and so on. And you can see storms and everything else over the period of those reports actually having an effect. And yet, once you get to 1970, you have an unholy alliance of problems where you have the drainage of the River Inny flowing into Lough Sheelin, creating a huge amount of sediment. You have a situation where you have huge pollution problems emerge very quickly because of pig slurry, and you have 2 or 3 really, really cold, stormy Mays in a row. And as a result of that, as I say, the mayfly had almost disappeared by the mid-70s, and yet again it has recovered. So what then are the recommendations? And again, we'll be putting some flesh on the bones of this as we write the report. But it's very obvious, and we've said it on numerous occasions, that we need to be looking at specific areas in each of these lakes in a much more intense way. Certainly looking at what our citizen science community can do for us. Pete, who's with us on the call, Pete has actually put in some of these little temperature probes that you can see on the right-hand side into Lough Carra already. So those little temperature probes are relatively cheap. They can go in, they could be twinned, as Pete has done, with light intensity meters, so that we can actually have a measurement of the water temperature and the light intensity in similar little units. Anglers could take water clarity readings, which they have done under other LawPro projects in Donegal very successfully, using this Secchi disc, which is the black and white disc that you see at the top of the screen. And where that disappears, that is the clarity level, if you like, in the lake. So if you can see it down at 3 or 4 or 5 meters, you're doing quite well. If you can see it at 2 or 3 centimeters, you have a really serious problem. this was a suggestion then that we got from our chemist. So it just shows that if you bring somebody in who hasn't done this sort of thing before, they state the obvious, which you should have thought of. I was raging. I didn't think of this myself. But Margaret, who couldn't join us this evening, she suggested that one possible approach in terms of quantifying what was happening during the hatch was to simply trawl the surface layers of the lake using something like the drop net that you see here. That's just there as an example, but with a much finer mesh. And you could collect the skins or the exuviae of the mayflies after they've hatched. You'd also be able to pick up some hatching nymphs. And if you did that in a stratified way over the 24-hour period in specific areas of the lake, that might give you the beginnings at least of a quantitative assessment. And Rick, who had to leave us a few minutes ago, that was with us earlier from the States, Rick has done this with chironomids, and it has proven to be very successful. The length frequency distribution of the nymphs is a very good way of giving you an idea of when the nymphs might have been laid, because you can see the different sizes. And for example, as I mentioned several times, Loch Cara was fantastic because you could see that you had a huge mixture of different sizes. And we were able to show that there was 5 or 6 different choices that a mayfly could make in the past in Loch Cara. So it could hatch after as little as 9 months. And yet in some situations, it took 2 years, depending on the conditions, depending on when the egg was laid, depending on the air temperature or the water temperature. The other thing that might be worthwhile would be to put in one of these little mini met stations that people use in their garden. Maybe a local interest group, a community group could actually install and monitor one of these that will give you very good local information on the wind direction, the temperature, the rainfall, the sunshine. So I think those sort of areas for the citizen scientists, we could certainly build with LawPro's help. We could certainly build on those, and we can give very good guidance, I think, at this stage, and suggestions in terms of areas where that work might be carried out. In terms of the actual science itself, well, first of all, to say that the questionnaire was a great success. I'd love to see that extended. Obviously, we haven't covered any rivers at all, and I have a particular interest in rivers. And the mayfly populations in rivers are showing very strange fluctuations, and they need to be looked at. We haven't looked at some of the other bigger lakes. For example, some friends of mine were out with some journalists fishing on Loch Gara this year, and they saw the most extraordinary hatch of mayflies. They rang me from the lake shore. They had never seen densities of mayfly like it in two afternoons. So that shows that we still have a lot of work to do. But 2 things that we feel are really urgent. We think that in some areas of these lakes, at least, there should be a proper floral survey carried out to look at the extent of the flora and to speciate the different plant species so that we can get a handle on what's happening in terms of this spread that, as I mentioned, both myself and another colleague have just noticed by chance, both in rivers and lakes. And again, to emphasize, this isn't invasive species. These are our natural species doing different things. And that's not surprising, I think, given the conditions we're finding in our water and air systems at the moment. And of course, the sediment survey that hopefully Margaret will embark on, we really need to know in scientific terms what we're talking about. What are the key features that the mayfly is looking for? You saw the little guy there that was making the burrow, and all of the material that Ross mentioned, where he mentioned rocks and gravel and everything else, that's underlaid by this marly soft sediment. It has to be, because they can't get down into the bed of the lake unless it is underlaid by those sediments. So as I say, it is quite a subtle mix. And of course, we have huge changes now in terms of AI. We have new sensor technologies emerging very quickly. We have satellite technology now that can actually tell us to within 2 meters square of the surface of the Earth what's actually happening. So over the next 5 to 10 years, we have a lot of opportunity to actually look at something like this in more detail. So just to end then with the final slide, the team were anxious to emphasize that we're only really the spokespeople for everyone else this evening. Everybody has been so helpful to us in this particular project. LawPro, in terms of Connor and Tom, who kicked the ball out and got the whole thing rolling, Bernie, of course, who's with us tonight, my colleague Luke Dre, who's been helping us now for the last several months, but particularly our field support volunteers, my Santa's little helpers, Pádraig Traynor on Lough Conn, Paddy Gargan on Corrib, Kevin Beattie and Neil on Mask, John Byrne and Dennis Matthews on Sheelan, and Michael and Jim then on Lough Cara. And just to reiterate again, my thanks to Brian, who's with us this evening, and to my friend Paddy Orr, who loaned us equipment then for sampling the lochs rather that we examined.